So this talk is about the Deephaven v2. The goal of the project is to make the server-side Python experience better by making a Pythonic package. So what we did in this project, basically we pretty much hit the JPY reference and we wrap everything that needs to be public, and internally we just hold a we use the naming convention to make the JPY object mark it as private, and we also curated what we want to expose. Now, if you expose a JPY object directly, basically anything, all the public method properties available to the knowledgeable Python developers. The other thing we did is we tried to be conformant with the PEP 8 style guide of Python. The namings, the first thing you notice would be we use a lot of snake case namings for functions, variables, all that. For classes, the convention in Python also use camel cases. For module names, it would be lowercase snake case as well. And we try to be very consistent in our naming. There's still some inconsistencies found, but that's the goal we strived for. We add a lot of type hints whenever possible, and this would help developers that want to use static type checkers like MyPy, PyLint, all these kind of things. It won't be on the same level as the true static typed languages like Java, but it's a huge help. We also handwritten all the docs in for all the public, sometimes even for private interfaces, and so there won't be any more auto-generated docs from the Java docs, and you wouldn't see any overload descriptions or direct reference to Java names, all that. So just overall much cleaner, and give you an impression that it's pure Python, although it is just a wrapper. And we also introduced a new custom exception called DH error, and this we pretty much try to catch all the Java exceptions and wrap the Java exception inside this custom exception, and then we try to filter it and try to extract the root cause of the Python exceptions, and there's a way for you to retrieve that. Even in the web UI, the reporting of the exception, I think just the few lines you should be able to figure out what's really wrong without having to go through the full Java stack, exception stack. And we also reorged the package structure. We got rid of all the generically named modules like tools or utilities, all that doesn't give you too much meaningful information. And we strive to make sure that all the names are quite explicit in its meanings. The plot API, I think Chip has done a lot of work to basically rework the autogen of the API. It used to be we have sometimes 80 overloads, and we basically condense them into just one function with enough parameters and enough type hints, and so that we can achieve the functionality of the old API, but it's much more Pythonic, much more concise, and friendlier to use. And also for this project, we wrote a lot of new test cases, and pretty much for every public function features that we have a corresponding test case for that. All right. So I think for now it's just me doing all the wrapping. I guess in the future, I think Amanda and Matt already tried. You might want to wrap something or add something in the package. So here I want to offer some rules and tips, strategies to do that. So when you need to wrap something, you always wrap the interface. You don't want to wrap the concrete class. I don't think we have cases where you would need something useful in a concrete class that is not available in the interface that the class implements. So that's kind of how we go about that. And for all the static methods, usually it's suffice to just define some module level functions to wrap them. Right? For Java enums, you write a Python enum to wrap it. And for the Java constants, you can place them in the module locals, or we have a constant.py that's really system-wise, and you think that's the right place to place them, they should go there. Always catch GPY exceptions whenever you need to cross the boundary to call something in Java, and then wrap them in the DH error, the custom exception I just mentioned. You need to document every public function, variable, class members, methods. I forgot the modules. In the Google style docstring format, and remember to always write a test case for the functional parts. So some coding stuff. You must always follow the pipette naming conventions. When you wrapping a Java interface or class, always inherit from the JObject wrapper, which is an abstract class in Python, and it has some useful properties that can be used in a plugin environment or in a situation where you don't know the exact wrapper class, but you want to get to the wrapped Java object, or you want to unwrap it, stuff like that. So always do that. When possible, always use the Python data structures to for your parameters, right? If your Python Java method accepts, for example, Java array list, but your Python wrapper should accept a Python list instead of an opaque Java array list. So I mean that's probably just common sense. The wrapper module has some nice utilities. I just mentioned that. We also have a Java compatible module. It has a lot of utilities for converting Python data structures, the common ones to the common ones in Java, in case you need to do that conversion. Don't reinvent the wheels. We have a new dtypes module that define all the common data types that our engine uses, and also the NumPy types that it maps to. And so, whenever you find yourself in need of doing some type conversions or find the right type for your data, you should look at this module first. And when you have a very deeply nested names that sometimes it's harder for user to use, always use the init.py to import that there, and so that it will be a much shorter reference for the Python users. Yes, this is what I encountered, testing ticking tables. It's a little tricky, and Ryan told me some ways to make it, deterministic, and so in our it should be test-based py, which is a base unit test class. We have some help functions that you should look at and try to use that in your tests. I was planning to do a live wrapping example, but I don't think that's really necessary. Any questions?
Can you mention a little bit about the wrapping function that you were using in the URI that automatically looks at types?
Yeah, that's in the wrapper.py. Let me bring this. Right. So in the URI, because we don't know what the resolved the resolved object can be anything basically. So we need a way to wrap it if we have a corresponding wrapper for it. So this function basically does that for you. The way we did it is we keep a list of the wrapper class, and we let me see. I think we basically inspect the object, and then we're trying to find a wrapper class that is of the same type, and it can be directly initialized. And yeah, and that's pretty much it. This unwrap function basically just because the wrapper has a generic or universal property called JObject. So if you don't care what or if you don't know what the wrapper class is, but you know it is a wrapped object, you can use this unwrap function to give you back the raw JPY object that you can use maybe in your Java code or when you in calling your Java method and all that. I think we use it in the app mode. We use the yeah, I think we used it in the app mode. Oh, it's not there. It might be useful in the future when we do some generic plugin framework that can handle or can is expected to handle different types of objects.
One thing I was going to ask, is there still a lot of Java code gen under the hood for filters, or is there more native Python support for anything like that?
By filters, you mean what?
Like just a, where filter, is it all still backed by code gen?
No. It's let me give you an example here. somewhere. Yeah. So we now have a filter wrapper that allow you to construct a filter, programmatically. And yeah, so this is still pretty bare. We're gonna have to add more stuff there. Right now, we only have the regex filter, but any special kind of filters will go in there.
Yeah, you can think about one of the major things that was done is, multiple function signatures were collapsed into a single function with name parameters.
Right. So the plot one is a really good example. If you look at this, let's say we're gonna do and you can see that now, we have a lot of named parameters, and each parameter can be of different types. And inside, we actually check all the combinations and call the appropriate Java classes, Java method. And this
Okay, yeah,
is,
great. I was hoping that would happen so we could move towards ahead of time compile. So getting one step closer to be able to link Java into a .so, so that way Python could invoke a .so and just skip the JVM altogether. Sweet. Someday.
oh, okay. Sure.